All right, good morning everyone. So this is the first session for today in the SUSE Theater. The name of the session is Why You Want to Encrypt Your SAP HANA Data. And you probably already are aware that there's some ransomware going around on the internet, WannaCry, that has the capability of encrypting your HANA data, but doesn't give you the key for de-encrypting. So this is about encryption. Encryption is a technology which is great. It can be used for good and for bad. And we've seen in the public how it has been used for bad. We at SUSE use it for good. Talking about encryption. You can use encryption on a couple of IT devices, and there are so many IT devices around. I did a rehearsal and I asked the audience to name those devices here, and we do the same here to get all of us on the same page. So I have a giveaway, and I want to ask you, what is the first device on the left side? What's that? A phone. Here we go. It's getting harder, okay? That was the easy part, okay? The next device is a laptop, right? The third one, USB stick. The fourth one, it's a server with virtualization on top, on-premise. And the fifth, that's the cloud, right? Hosted, a hoster, or the public cloud, whatsoever. So, the first three have something in common, and that is, it is accepted to use encryption on those devices, right? Why would you use encryption on those devices? People get access to it. Those devices can get lost easily, very easily. You lose your phone, you let people get access to the photos, maybe your email account. On the laptop, I mean, it gets lost or stolen from the trunk of your car. A USB stick where you have all your sensitive data on. I have a USB stick my whole life, 15 years of IT, all the stuff is on this thing, and of course it's encrypted. And I have a backup, of course, several. But if I lose that, someone will have my identity, all my passwords, all on this thing here. So, and sometimes it's a company policy that you have to use encrypted devices, encrypted company phones, encrypted laptops, and so on and so forth. But what about the server and the cloud? Question, why would someone use encryption on a server? And the answer is not because it can get lost, because if a server gets lost, you have different problems. So it's not about losing the server. So why would someone want to encrypt data on a server? Any guess? It could be hacked, yes. Here you go. But not only that, there might be regulations. Maybe your customer or you are in a business or in a vertical where you have to encrypt the data. Anyone from a security team in this audience? Okay, those folks are paranoid. That's why they're so good at their job, because they are paranoid. So those security folks they want to have everything ultimately secure. And if the security officer is a good buddy of the CIO, guess what? You have to encrypt all the stuff on the servers because they are best friends. Another reason for encryption on the server is you can throw away the hard drives afterwards. You can just throw away the server, nobody has the key, you don't need to erase the data on the hard drives. You just throw them away. It makes the asset management easier for the servers. Why would you use encryption in the cloud or in the hosting environment? The data is not in your premises, it's somewhere else. And again, coming back to regulations, it's better to encrypt the data if it's not running in your data center. For example, credit card information, personal information, and so on and so forth. Of course, the cloud cannot get lost, obviously, but both have also in common that as a customer, you can leverage that for your corporate identity and marketing if you say to your clients, all the data we have is encrypted. It gives you more credibility in case you store customer data. So that can be part of the story, because maybe your clients are in the defense space or in a vertical that needs that. This can be used for supporting your message. So we now identified that it's a good thing to have encryption, sort of. The challenge now is, and I call that comprehensiveness of system landscape. Is the landscape looking like that? Obviously not. So the landscape looks more like that. You have a couple of 100 servers, even more virtual machines nowadays. You have containers on top. And this is just on-premise. In the cloud, you have even more virtual machines, and so on and so forth. Guess what? and this is my thesis, you will need at least one monkey per server, because one of those servers reboots, you need a monkey to enter the password for the disk to be encrypted again. If you have 1,000 servers, all have encryption on hard drive because you want to throw the disks away, how do you handle that? Do you want to have IT staff sitting around for hours typing a password? No, you want to have monkeys. But the problem with monkeys is they can actually learn the stuff on the good side of things, but if they learned it, they get bored and goof around with the system. You don't want to have that happening. So the problem is how to automate all of that. So paranoia from the security folks is we need to have the system secure, but always security versus usability. So this is really not usable. This is the problem of using encryption in the data center. A server reboots at night, you have to enter the password. You don't want to have the key stored on the disk. I've seen customers doing that. And like, yeah, well, why do you store the key on the disk? I mean, yeah, we can automatically unlock. Yeah, but someone has the key is on the disk. Like, yeah, whatever. So the thing is now what we invented, sort of, is a key server concept. Okay, a key server concept. It is part of SUSE Linux Enterprise Server 12. You set it up with a simple command line. 1 minute thing. You provide a password. It's like the master password for the key server. You have a certificate because you need to have that certificate in order to have an encrypted network connection with all the clients. You have a directory, a storage where all the keys of all those hard drives you want to encrypt later are stored, and you give a network device on which the key server is listening. It takes 1 minute to set up that key server. That's a pretty easy thing. What happens next? You have a server, for example, a HANA server, and there's a directory or a volume or a partition that you want to encrypt because it holds, for example, the HANA log volume data. HANA data volumes can be encrypted through SAP HANA itself, log volumes not. If you want to have those secured as well, because they still hold the last 10-15 minutes of your transactions, you want to put those on an encrypted disk. Maybe you want to put some log files on a disk, the home directories of server. So you can actually choose what kind of disk or directory on the Linux server you want to encrypt. So after you made up your mind, okay, I want to have this particular folder. Let's say it's the HANA log volume folder because that's crucial data, what's in there. You then have to execute a couple of, you execute just one command and you are asked a couple of questions. Those questions are, give us the host name of the key server because we need to know where the key server is. Second is we have to enter the password. This is just for the setup. It's again, only for, that's a one-time activity here. You put in the password and you have to provide a certificate because you need those certificate for authentication on the key server because we don't want anyone asking the key server for the keys, so we have to establish that trust. After you have entered this kind of information here, a key is generated. And by default, we generate a 500-bit key for encryption of the volume. That's the default, and you can, of course, if you like, increase the key length. So the maximum key length you can choose is 4096 bits. On the good side of things, that's pretty much ultimately secure for now, maybe for the next 100 years. So this is ultimately secure. That's on the good side of things. But on the bad side of things, what's the drawback of having such a long key? Anyone? Performance. That's correct. The longer the key, again, this is security versus usability. You have more security, but from a usability perspective, you have horrible performance on the disk. Horrible. So we chose, and it wasn't really a gut feeling. I wasn't sitting there rolling dice and say, oh, 512 bits is a good number. It was like it was a consideration of acceptable security with 512-bit key encryption. And from a performance perspective, the drawback wasn't as big. The performance is not that big. But of course, all of that depends on first, the I/O pattern of the application, what kind of I/O pattern it is. And of course, second, the disk you are using. Because on a spinning disk, it's much slower than if you use, for example, an SSD. And third, you could have, for example, additional crypto cards in your server that also speed that things up. So that's a one-time activity. The key is generated. What happens next is the key is sent to the key server, it is stored at the key server, and the disk is encrypted. That's it. The disk that is encrypted can be empty or can hold data already. When it's empty, the process is finished in a couple of minutes. If it holds data, it takes a while because the data needs to be copied somewhere else, and so on and so forth. But it's possible that if you have a HANA log volume already, that you can actually encrypt in place. And again, the key is stored on the key server. And obviously, if that is the cloud, that thing runs on premise. Technically, you can run the key server in the cloud as well, but then it's again not in your premises. And the idea is to have your keys in your premises, in your data center, just for the peace of mind that you own the stuff. Okay? This is a one-time activity. You are with me so far? All good? Good. How does it look when we have like a real-life scenario? So, we have a key server has a couple of keys, a lot of keys in the key server storage. And we have, for example, one server where a disk has been encrypted using this functionality. Once a disk is encrypted, it gets a fingerprint. That fingerprint basically says, okay, in that fingerprint we have the IP address or the hostname of the key server. And of course it's the identity of this particular disk, because we don't want anyone asking for a key. I mean, you ask the server, can I have the keys? And the key server sends the keys out. That's not going to happen, of course. We need to have the fingerprint here. So, 3 scenarios we are now walking through. First, a simple reboot. What happens if we reboot that server with a disk that has been encrypted using this feature and having the fingerprint? Second, if there's a power outage. Obviously the first and the second are very similar because the server starts or reboots afterwards. And the third one is cloning that thing if it's, for example, a VM. What happens if we clone a VM with a particular fingerprint? What happens? So let's focus on the first 2 scenarios. What happens is the server boots, server starts, and the Linux boot system that's called systemd is checking the hard drives, and apparently it detects, oh my god, there's a hard drive that has been encrypted using this functionality. It reads the fingerprint, gets the information from the key server and says, okay, I need to talk to a key server to fetch the key, because you don't have the key locally, because maybe the system runs in the cloud and you don't want to have the key in the cloud. So with the TLS encrypted communication, the server asks the key server, hey, I'm here, I need a key. Then with the fingerprint and authentication happens, identity is confirmed, key server says, okay, this is you, yeah, you get that particular key, and the key is returned to the key server. The volume is unlocked and the key server is thrown away. The key is thrown away. The key is not on the server. On the server. It's only on the key server. Still with me? Very easy. Very good? All good? Good. So now the problem arises. What is the problem with scenario 3 when you clone? Pardon me? Correct. The identity is not unique anymore. And in a scenario where someone, for example, is copying your virtual machine that has that secure data, is copying that virtual machine, it's copying the identity of that virtual machine. And if the virtual machine is somewhere, is started up, having connectivity to the key server would say, oh yeah, here you have the key and the data is unlocked. That's a scenario where that feature wouldn't bring any value to the customer. So what do we do about that? We honestly cannot do much about that because the identity is copied. However, there's a thing. We built in a heartbeat functionality. That means the key server is monitoring all the servers which have currently a key in use or have a volume being unlocked so far. The heartbeat happens every 10 seconds and the key server keeps track which server of the keys it has are currently in use. Then you can configure how often a key can be used. The default is one time. A fingerprint can only be used one time or can only be online one time. By that, of course, you prevent the scenario that if someone steals your VM or copies the VM, that they cannot unlock it as long as your server is running. That's a good thing. The bad thing is if you have, for example, a scenario where you actually have a scenario where you copy VMs in your data center, that prevents you of using that feature. Again, you can configure the number of concurrent mounts of that thing. You can also configure the firewall that only certain IP addresses, for example, can fetch the key. So there are ways to do that. But again, security versus usability. There are a couple scenarios which actually are more secure but prevent, again, usability to a certain extent. So, with that feature, you basically can now, it doesn't matter if you run in the cloud, it doesn't matter if you run in the cloud or on-premise, you can secure your systems. And I actually use that at home in a simplified version if I boot up my laptop, it has some stuff, a volume on it, and if I'm at home, it connects to my key server at home and unlocks automatically the stuff. Or the other way around, it's not for me, it's for my wife. Because my wife, I don't want to have the laptop of my wife and the photos on it unencrypted. But if I tell her to enter a key all the time, I cannot sell that feature. But with that feature, even in private life, I can let her use a security feature and she doesn't have to enter the key, which is cool. And if the laptop is stolen, it's not in our network, so nobody gets the key. So we got a few more people. Anyone from you from a security department? Still not? The paranoia guys. So the source code we have is open. It's open source code. There are commercial versions for that. You have to pay a lot of money for those. And maybe they are very good. I don't know. I didn't look at those. This stuff comes for free with Lesser SAP applications. It's open source. You basically can ask your security folks, fetch it from there. There's the link. Fetch it, compile it yourself, run it yourself. You're on your own. You can do that. But in open source, it works differently. You look at that, you let your security folks review that. If they find something they're not familiar with, or if they find something they want to have changed, they upload the stuff, push it upstream, we take it, put it into the distribution. You get it anyway for free, and then you get the support for that feature. It's cool, isn't it? This slide we are actually at booth 559, so this is redundant, and that's the end of my presentation. Any questions from you?